Hello everybody, welcome back to Math 1351. We're more on math because we're going to talk about Chapter 9, Section 1, homework assignments. Alright, let's look at the first question. Two dice are rolled. Find the probability that the score of the dice is 6. Well, we talked about during lecture. Here are the possibilities. If you have two dice, if the smallest that can come out is 2. It only happens once. And the biggest is if they both are 6s, it equals 12. Everything else in the middle has to happen. So our question is asking, you roll 2 dice, and what's the probability of getting a 6? So how many ways are they getting a 6? 3 and 3, 4 and 2, 2 and 4. There's 1, 2, 3, 4, 5. There's 36 of these possible combinations, so it's 5 over 36. The probability of getting a 6, it occurs 5 times out of 36. The probability of getting a 12, looking at our chart, getting a 12, it only happens one time out of 36. So it's 1 out of 36. So it's B. Okay, and the next one. 2 dice. Find the probability of getting either a 4 or an 8. They're independent events because why are they independent? You can get a 4, or, which ors means addition, you can get an 8. You can't get an 8 that's also a 4. So that's why they're independent events. We know that there's 36 possibilities. So how many ways can you get a 4? 1, 2, 3. How many 8? 1, 2, 3, 4, 5. So 3 and 5. Add them together. 3 plus 5 is 8. And of course, we've got to simplify. To be simple, 2 goes into 8 4 times. 2 goes into 36 18 times. They're both even, so again, 2 goes into 4 twice. 2 goes into 18 9 times. So the answer is 2 over 9. Alright, 2 dice are rolled. Find the probability that the score of the dice is 5, or that both dice shown are the same number, or doubles. Okay, so we want either a 5 or doubles. Are they overlapping? In other words, can you make a 5 out of the 2 of the same dice? No, it's an odd number, so that doesn't work. So they're both independent events. If they were dependent, if they could happen at the same time, then we'd have to subtract their overlapping. But since they're independent, we're good to go. So let's look at this. Now 5. 1, 2, 3, 4. So it could happen 4 times. Now doubles. 1, 1. That's 1. 2, 2. That's 2. 3, 4, 5, 6. So the only way you can get doubles is on the even numbers, 6 times. Add the top. 4 plus 6 is 10. They're both even. 2 goes into 10 5 times. 2 goes into 36 18. So it's A. 5/18. Alright, now use the next picture. Because now we're talking about a deck of cards. A single card is drawn from an ordinary deck of 52 cards. Find the probability of getting a red card. And here's a standard deck of cards. A standard deck. There are 52 cards. You have clubs, spades, hearts, and diamonds. And there are 13 of it each. There are 52 total. So 13 plus 13 plus 13 plus 13 is 52. So the question is asking, what's the probability of getting a red card? Since half of them are black, half of them are red, the possibility is, so the probability of a red card. We know there are 52 cards, 13 diamonds, 13 hearts, 13 plus 13 is 26/52, which is 1/2. A single card is drawn from a deck, ordinary deck. Find the probability of getting a queen. So a deck of cards has 52 cards. How many queens? 1, 2, 3, 4. Each suit has 1 queen, so it's 4/52. They're both even, so we can simplify. 2 goes into 4 twice. 2 goes into 52 26 times. So again, 2 goes into 2 once. 2 goes into 26 13 times. Now again, since a queen happens in each suit, so it's 1 queen out of 13 possibilities. So it's 1/13. Single card is drawn from a deck of cards. Find the probability of getting a black 7. Again, we have 52 cards. There's a black 7, there's a black 7. So you have 2 possibilities. 2 goes into 2 once. 2 goes into 52 26. So it's 1 out of 26. A card is drawn from a well-shuffled deck of 52 cards. What is the probability of drawing a face card or a 3? So probability of getting a face card, so or means plus, the probability of getting a 3. Each of these, again, there are 52 cards possible. How many face cards are there? The face cards are these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 face cards possible. How many 3s? There's 1 in each suit. 1, 2, 3, 4. So it's 4 possibilities. Same common denominator, add the top. 12 plus 4 is 16. So we know that, well, 4 goes into each of these. 4 goes into 16 4 times. 4 goes into 52 13 times. So the answer is B. Okay. That does it with these. And I'm going to send you those charts in your email. A bag contains 5 red, 4 blue, and 1 green. So it's a total of 5 plus 4. So a total of 10. So 5 plus 4 is 9 plus 1 is 10. So n equals 10. So it's saying, what is the probability that it's not blue? So not blue would be red or green. So it's 5. 6 of those out of 10, they simplify. They both have a 2 in common. 3 out of 5, which is C. What this means is, if you drew, you had this bag containing all those marbles, so, and you drew 5 times, you wouldn't get a blue 3 times. That's what that means. What this one means, if you had a deck of cards and you picked a single card 13 times, then you would get 4 events would happen. It would be a face card or a 3. It would happen 4 times out of 13. That's what that means. Okay, a bag contains 17 balls numbered 1 through 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Find the probability of selecting a ball that has an even number. So there's 1, 2, 3, 5, 6, 7, 8. We have 8 out of 17, which is B. All right, everybody. Good luck in your homework.